All right, I know you guys love slope so much. We're going to have day 2 of slope. So we're going to talk about the formula, but I just want to really illustrate how we can count slope from a graph. All right, so let's remind ourselves what rate of change is, right, when we're talking about slope. It's a ratio that shows how one variable changes with respect to another. Now remember, a ratio is a fraction, okay? So on a linear graph, this is called the slope. The slope of the line. Slope. All right, the slope is written as a ratio, right? AKA fraction of the vertical change, the rise. This is something you'll also hear if you don't remember hearing it before, to the horizontal change, that is the run, right? So we have rise over run between any 2 points on a line. This remains constant, meaning the slope does not change for any 2 points on that same line. So it's constant. All right, the slope is written as a, what did I say, ratio, aka fraction. In simplest form. That means you must reduce. Simplest. Simplest form. I don't know if I spelled that right, but simplest. Yeah, good enough, good enough. All right, so slope is written as a fraction in simplest form. The variable for slope is the letter m. I did talk about that on Friday, not sure if you remember. So remember, it's always the rise over the run. Okay, so there's 4 different types of slope. I did talk about this on Friday as well. So let's talk about them again. All right, so we have our run-of-the-mill. Here's our positive slope, right? Going uphill from left to right. Right, then we have our negative slope going downhill from left to right. I'm going to type these words in because this is tough to write on here. Right, and then we have our basic old zero slope. Right, that's a horizontal line. Don't forget that. Zero slope. And then we have the super free, the vertical line, which is undefined slope. Undefined. Undefined. All right, and if you need to pause this video so that you can take these notes, because they are important to use as a reference so that you know what you're doing, then go ahead and pause the video now so that you can copy down what I have on this page. I'm going to keep going though. Here we go. All right, next we're going to talk about slope from a graph, right? M equals rise over run. Rise over run. All right, when we talk about the vertical rise, we start at the lowest point. So we're going to count how many units, right? And it needs to be on an exact coordinate. Notice this point is right here. I wouldn't pick a point that was right here because it's not an exact coordinate. It has to be, this is the point. Let's see, it's -2, -2. So we are going to count 1, 2, 3, 4 is my rise, so that's my numerator, and then my run is going to be, let me change color so we can see it really good, 1, 2, 3, 4, 5. That is my denominator, rise over run. That's my ratio, my fraction. It's already in its simplest form, so I don't have to reduce anything. That's totally fine. All right, let's take a look at number 2. Let's count our vertical rise. So we start at the lowest point. 1, 2, 3, 4, 5, 6. That's my rise, right, over my run. 1, 2, 3. 6 over 3 can, in fact, reduce to 2 over 1, or just 2. So this line in example 2 has a slope of positive 2. All right, so both 1 and 2 were both positive slopes. Let's look and see what happens when we have negative slopes. Remember that the x and y intercept are nothing more than number lines, right? Not intercept, I'm sorry, axis. The x-axis is a horizontal number line, right, where the center is 0, numbers to the right are positive, numbers to the left are negative. And the vertical axis is the y-axis, where numbers above 0 are positive, numbers below 0 are negative. All right, just a little refresher. Let's find the slope from the graph. We start at the lowest point. Here it is. So we're going to count 1, 2. So my rise is 2. But now my run is to the left. So that is making it a negative. 1, 2, 3. Oh my goodness, where's it? 4, 5, 6. Negative 6. All right, when you write these, especially if you're doing an IXL, just put the negative sign with the numerator. I just don't want I don't want it to be wrong. I mean, it doesn't look wrong to me, but I'm not sure if those answers will be accepted or not. But we do need to reduce this, right? 2 over negative 6 is negative 1 over 3. As long as there's a negative somewhere, that's fine. If you're writing it by hand, if you just wrote 1 over negative 3, that's fine too. I just wanted you to be careful when you're putting them in for the IXLs, okay? I don't know if this would be accepted. I guess I can experiment with that. All right, let's look at number 4. We're going to count the rise over the run. We start at the lowest point. So again, 1, 2, 3, 4, 5, 6, 7. So 7 is my rise. And my run is 1, 2, 3, 4. Remember, I ran to the left. That makes this a negative slope. Negative 7 over 4, 7 over negative 4. All right, so it's not terribly hard. We can all count units, right? We have enough digits on our hands, and if you have to, take your shoes off and count your toes, okay? All right, number 5. How can we count the vertical rise over the run when it's a vertical line? Let's refresh our memories here, folks. A vertical line has an undefined slope. There's nothing to count. There's no computations we need to do. So we're just going to write the word undefined. And I'm going to type it because for some reason, my handwriting is getting worse. So it's undefined. All right, that's easy. Vertical line, undefined slope. Don't forget it. Very important. All right, let's look at number 6. We're going to count the vertical rise. 1, 2, 3, 4 over the run. 1, 2, 3, 4, 5, 6, 7, 8. Wow, that really ran far, right? Remember, rise over run, 4 over 8. We have to reduce this, okay? They do have a common factor of 4, so this should reduce to 1 over 2. So number 6 has a slope of 1/2. All right, I just want to refresh your memory again, the slope formula. So for number 7, I'm going to apply the slope formula as well as count the rise over the run from the graph. So remember the slope formula, m equals the difference in my y, so y2 minus y1 over x2 minus x1, okay? So if we look at our 2 ordered pairs, let's just say that this ordered pair right here is my x1, y1. This is 1, 2, 3. So this is the point 3, negative 2. So I have 3, negative 2. My second ordered pair will be my x2, y2 is right here. That is negative 1 for x and positive 1 for y. You can see that negative. Okay, so it was negative 1, positive 1. All right, remember, I always put my little x1, y1 underneath. Takes a second. This helps me keep everything together so that when I plug it in, I know I'm plugging in the right number. I look at the formula. Y2 is 1, minus y1 is negative 2. Remember, minus a negative, that becomes addition. In the denominator, I have negative 1 for x2, so negative 1 minus x1 minus 3, like that, all right? 1 minus negative 2. Remember what I said? That becomes addition here, big fat plus sign. So 1 plus 2 is 3. Negative 1 minus 3 is negative 4. So this is a negative slope. Remember, you can write it like negative 3 over 4 as well. All right, let's count from the graph to see that this, remember this is number 7, that we get the same slope counting the rise over the run. So 1, 2, 3. Okay, numerators are 3. Looking good. Still the same. And now we're going to run. We're running to the left. That makes it negative. 1, 2, 3, 4. Negative 4. All right, nice. Well, I can tell you right now, counting it from a graph or calculating it with the slope formula, obviously the slope formula takes a little more time and the graph is a little simpler. All right, let's look at number 8. Wow, this is a lot. So we are going to have to count our rise. 1, 2, 3, 4. All right, that's my rise over my run. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Whew. That was a run. All right, 4 over 10. You must put it in its simplest form. So please reduce. 4 over 10 reduces to 2 over 5. They have a common factor of 2. If I divide top and bottom by 2, I get 2 over 5. All right, cool beans. All right, take a look at these 6 examples here. Pause the video. Zoom in if you must. Calculate the slope. You can either use the 2 ordered pairs that are given and apply the slope formula. I'll remind you one more time what that is. That's y2 minus y1 over x2 minus x1. And then you can also count the vertical rise over the horizontal run. Make sure you're notating if it is positive or negative. Rise over run, all right? So pause the video. Write down on your little piece of paper that you're taking notes with the slope of 9, 10, 11, 12, 13, and 14. Okay, for number 9, you should have got negative 4. Number 10 is 0. It's a horizontal line. Number 11 is 5 over 3. But it's negative. Come on now, you silly bean. Number 12 is 3 over 2. If you had 6 over 4, you would lose points because it's not reduced. In number 3, you had a vertical rise of 7 and horizontal run over 7. 7 over 7 is 1. And number 4 is negative 1 over 5, or negative 1 step. If you got those all right, give yourself a pat on the back. You're amazing. Maybe give yourself clapping. Be happy, be joyful. Slope is not that hard. And here is your assignment for today. So your bookwork is on page 233 to 235, numbers 29 to 31, 41, 43, 44, and 45 to 59 odd only. Remember, those would like to hit your problems, so try to keep you fresh. All right, let me know if you have any questions and have an awesome day.